Hi, we are doing the 3.3 notes, which is evaluating function notation. We're actually starting on the back of this one. So it looks like this up on the front, 3.3, the exploration, and the number 2 exploration. We're actually starting on the back together. So the first thing we're going to do is talk about, well, what is function notation? Uh, the first thing I want to stress to you guys is that this is not different than what we've been doing so far. It just looks different, and that's it. It is not different, it looks different. It's like a different way of writing it. So, function notation always uses an F. So I'm going to do an example first. I'm going to show you an example of function notation. It's where I have like F and what it looks like first, like what we're used to seeing, I want to show you. So we're used to seeing like y equals 3x minus 2. But when we do function notation, we do it a little bit differently. We would say f of x equals 3x minus 2. Take a look at the similarities there. What changed? Well, I took out the y and I put in an f of x. Now we read this as f of x. This right here is not multiplying. You know how sometimes you see like 3p, or even sometimes you see 3 with a parentheses and then a p, something like that. That is not the same thing as what we're doing here. F of x never means f times x. It's not okay to say f times x when we mean f of x. F of x really means a function with x in it. F of x. It's a function of x's. And if we look at our function that we have here, it's made of x's and some numbers, of course, but mainly an x. So that's where we get f of x. This does not mean f times x. This is the thing that I'm stressing the most in this whole video. So if I'm talking to you today in class and you say something along the lines of f times x, I'm going to say, oh, you didn't watch the video. So I'm glad that you are watching this video. F of x does not mean f times x. So function notation is a different way of talking about functions that eliminates confusion. The reason that it eliminates confusion is because function notation allows us to have multiple different functions at one time and know which one we're talking about. So for example, we're not always going to have f of x. We could also have a different function called g of x, and this one could be completely different. So I'll do negative 2 plus 4. Oh, negative 2x plus 4. So completely different function. Now I have f of x, I have g of x, and I could do this with other letters also, but you get the idea that this f and the g, it's like it's the name of this function. So f of x is 3x minus 2. G of x is negative 2x plus 4. Notice that I can replace that equals sign with is. That's huge. I would make sure that I write that down in my notes. Equals means is. When we get to our evaluating these, which will be in a second, this is going to be really big. So make sure you have that written in there. Right now we're doing the exploration though. So this is going to be on your own. I'm going to do the first one with you. So this is back to that first page. Consider the function f of x equals negative x plus 3. Locate the points on the graph. So what we have to do here is we have to take negative 1 and plug it in and then see what we get out. Two ways we can do this. The first way is I'm going to plug in negative 1. So if I plug negative 1 in for x, I would get negative 1 times a negative, so this is this negative out here, then the x is negative 1, plus 3 negative 1 is, so negative 1 is 1, plus 3 is 4. The other way we can do that is by looking at the graph. Say, well, negative 1, that's my x value. Up, 1, 2, 3, 4. Oh, so it's right there at 4 on my y. Because this f of x, remember, secretly is just y. Excuse me. Remember, f of x is just secretly y. So on a graph, if it's looking for the f of x value, it just means the y value, 4. You guys can do B, C, and D using that same method. Remember, you're just plugging in 0 into the function, plug 1 in, plug 2 in. You can even plug 0, 1, or 2 into the graph and see what number comes out there. So you've got options. Okay, so now this is the meat of this assignment that you're going to have, is the evaluating what we're given here. And the thing that I can't stress enough, equals means is. So I'm going to read this. Evaluate f of x is equal to 2x minus 7 when x equals 4. Well, if x equals 4, that means that x is 4. What we want to do is we want to denote, we want to say, we want to show that we're plugging 4 into the x space. So here's what we do. We're going to write f of x equals 2x minus 7. But what is x? Well, x is 4. So I'm going to go in and there's 2 spots where I have x's. And I'm going to get rid of both of those spots and put 4 there. Now I'm going to evaluate. So I'm going to figure out what is on the right side. Left side does not change. We leave it as f of 4. So it's just like we're evaluating this side. Well, what is it? 2 times 4 is 8, minus 7 is 1. So here we have f of 4 equals 1. That's it, guys. Don't overcomplicate this. We leave that f of 4 as f of 4 because it does not mean f times 4. It's just the name. So it stays there. Here's another example. Evaluate g of 0 when g of x equals 5x minus 2. Well, take a look here. To get from there to there, what did I do? Oh, well, I took out the x and I put in a 0. So that's what I'm going to do in my actual function. G of 0 equals 5 times 0 minus 2. And then I evaluate it. As I figure out what that is. So G of 0, remember we leave that left side as it is, equals negative 2. Because 5 times 0 is 0. 0 minus 2 is negative 2. Here's another example that we have. For f of x equals 3x plus 1, find the value of x for which f of x equals 13. This is different, very different. These two are like the same problem, like the exact same problem almost. This one said, hey, x is 4. This one said, figure out g of 0. That's two ways of asking the same question here. So I had to do the same thing. I plugged in whatever value it gave me in for x, because these both said that x was that number. Here, it's not telling me that x is a number, it's telling me f of x is a number. Remember, equals means is, so f of x is 13. So what I'm going to do is I'm going to rewrite this. Say f of x is equal to 3x plus 1. What's f of x again? F of x is 13. So I'm going to get rid of f of x this time. Notice how different this is. My f of x is now gone. Now I can solve for x. And this is where I want to stress that we've been doing this. I'm going to subtract 1 from both sides to get 12 equals 3x. I'm going to divide both sides by 3 to get 4 equals x. It's like we did it backwards. So recognize, when I have x equals 4, I plug it in for x. When I have f of x is 13, I plug it in for the f of x. The whole f of x goes away and my number goes in there. For f of x equals negative x plus 1, find the value of x for which f of x equals 9. Again, this one is giving me f of x is 9. So when I write it, I write f of x equals negative x plus 1. And then I say, well, wait a second, f of x is 9. So I get rid of f of x and I put in a 9. Subtract 1 from both sides, 8 equals negative x. Multiply both sides by negative 1, and I get negative 8 equals x. That's my answer. That's my solution. Okay, so that's how we evaluate. Two very different ways of doing it. The next thing that I have here is how in the world do we evaluate when we have a graph? So the same idea needs to happen. Notice here, you know how way up here I said all we do is get rid of the y and replace it with an f of x? Well, think about it. F of x is y. Here I have a different name. This one's g of x. G of x is y in this example. First, it says evaluate g of 6. G of 6. So in what was here? What was in the parentheses before? Oh, an x. So that means my x must be 6. So 1, 2, 3, 4, 5, 6. I find my function. Oh, negative 1. Okay. So now I can say g of 6 equals negative 1. Now here it says evaluate g of x equals negative 1. That means I need to find my y, or sorry, that's positive 1, we're up 1. Here, g of x is negative 1. So g of x equals the y. G of x is equal to the y value. So that means negative 1 must be my y value. So on my y-axis, I go down till I find negative 1. That's right here. And I go across till I find my function. Now, what is the x value? 1, 2, 3, 4. Here, we have that x equals negative 4. Okay, you guys got this. You have a homework worksheet that is on the back. I believe in you. Remember, your quiz is coming up. We have one more thing of notes, and then the quiz is all yours. Thanks for working hard.